Hi everyone, welcome back to the CG Compositing series. I'm Tony Lyons, and let's jump into the next section of this series. Today we're going to be covering categories of render passes. We often might find that there are quite a lot of render passes, and I think it's useful to break them up and divide them into separate categories to help us understand how to use them and where to use them in our comp. We can divide up all the render passes by how they're used, and there are 4 main categories of CG render passes. So let's take a look at a table that I've made. The first thing that we're going to do is split it into 2 categories, like bigger categories here. One is going to be beauty rebuild passes. These passes will recreate the beauty render, as we kind of saw in the previous video. And on the other side, we have data passes or helper passes. These contain information and various things that'll help us when we're comping. The first category that we're going to talk about is called material AOVs. These are used to adjust the material attributes or the shader of the objects that are in the scene. Material AOVs include passes like diffuse, specular, reflection, subsurface scattering, refraction, texture or color passes, emission, raw lighting, etc. So here I have a contact sheet using the Redshift render passes, and these are all of the passes that I would lump into the material AOVs category. Now the material AOVs category is what we used to rebuild our renders in the first part of the series, where we did the simple rebuilds with the diffuse and specular and emission passes. Since AOVs can kind of just be a generic term to describe any render pass, it's a little bit unspecific, and so I think when people are talking about AOVs, they're talking about these passes in this category here, because it's a little bit more of a traditional way to render AOVs. When AOVs were first introduced, it was these passes here that were being used to rebuild the beauty. So I do think in my own terminology, when I'm using the term AOVs, I'm referring to the passes in this category. And in the future, if I do not say material AOVs, if I just say AOVs, I am talking about material AOVs. So I will try to say material AOVs, but yeah, just a little heads up if you see me slip up in the future. Material AOVs are changing the shader or the material of the object. Now I just went online and Googled some nice material packages, but these are the shaders that are being applied to the objects in the 3D world. And this is what the material AOVs is changing. So things like roughness or specularity or color or reflectivity, or if it's emitting light or not, these types of things that are happening on the material level. So this is what this category of render passes is used to manipulate. The next category is also in the beauty rebuild passes section. It is light groups. Light groups are used to adjust the individual lights in the scene. So you could break them out, for example, into key, rim, fill, HDRI, any light emitting objects, etc. Here we have an image of 3-point lighting, which is sort of a traditional way to set up lights in a scene. And you have the definitions here of key light and fill light and rim light. It's quite common to have these in CG, but it's not necessary. It's just a kind of an illustration of maybe different lights that you'd have in the scene. And the light groups are changing things like intensity or the color or the temperature of the lights. And so here you can see the Kelvin scale of the light temperatures, and you can see the warmer lights and the cooler lights to represent maybe candlelight or partly cloudy skies. So these are the types of features that light groups are good at manipulating. In our fruit bowl render, I've broken up every light in the scene into a separate pass, and I've just named them LG01, LGL2, etc. And LG just stands for light group. These could, of course, be named key and rim and HDRI. That is something you do see in some pipelines, but I just chose to name them light group 1, light group 2, just for ease of use. And if you'll notice, light group 7 is our emitting object. So it's our lamp in the background that was casting light in the scene. So that is also considered a light group because it is emitting light into the scene. On the data passes side, we have our third category, which is utilities. These are passes used in combination with other tools to achieve various effects like defocus, motion blur, relighting, etc. These passes might include depth, motion vectors, normals, position, ambient occlusion, UVs, etc. Here's a context sheet of all the passes from the Redshift render that are in the utilities category. So you can see we have the depth, ambient occlusion, normals, position. These are helper passes to help us achieve additional effects while compositing. The last category is IDs. And IDs are used to create alpha channels or mats for different areas of the render. These could be RGB IDs, object IDs, texture IDs, cryptomats, etc. So the IDs category could live under the utilities category. It could just be considered all utilities, but I do find the separation of the two pretty useful. The ID's sole purpose is basically to pull out an alpha or a matte channel, whereas the utilities have a variety of different use cases for different effects. It's not just limited to creating an alpha channel or a matte to be used elsewhere. So there is sort of a separation of the two, I think you'll see, but I did put a dotted line around both categories because they could be grouped together and they could all just be called utilities, but as we'll probably see, there's a little bit of logic behind the separation. Here are the render passes found in the ID category. So we have cryptomats, which we'll talk about later, and then we have some RGB passes. These are RGB object passes, so the objects are literally solid colors that you can separate later in comp. So I did include another pass, ID05, which I did kind of invent myself, but it's just for demonstration purposes. ID05 is an example of a texture RGB pass. So here we have the channels red, green, and blue, representing different sizes of noises and different patterns. So each channel would have a different pattern in it, which could be used, for texturing or other types of effects. So oftentimes when you're doing, say, character work, there will be an actual texture artist, that the person who does the textures for the character, they might create individual mats to help you isolate, the scales of a lizard, or mats for a face for maybe further color correction in comp. So this would be in the texture level, and this would also appear in this ID category. Here again is the full table with the 4 different types of render passes here. Once again, it's material AOVs, light groups, utilities, and IDs, and separated into bigger categories of beauty rebuild passes and data passes. Moving forward in this CG compositing series, I think what we're going to do is we're going to first focus on the beauty rebuild passes section, and we'll go over material AOVs and light groups and how to use them to help rebuild and recreate our beauty render. Then we will start to cover the data passes and showing how to use the different passes to help us do defocus, motion blur, relighting, and how to use cryptomats and our ID passes to isolate different parts of our render. I think I'll divide it up into these 2 sections, and then we'll do a deep dive on each one. The Nuke script that I'm providing for this video is not too much. It's kind of a node graph representation of the slides that we went over. So we have the bigger render passes, and then the 2 breakouts, the data passes and the beauty rebuild passes. And then inside you see all of the different categories. And I went ahead and I set up each of the renders, so Redshift, Arnold, and Octane, so you can kind of see the differences between all 3 of those render engines. So if I focus in on the Redshift table here, we'll see that I have the Redshift render, and I am doing a contact sheet for the material AOVs. And the reason why this contact sheet is working and it's not displaying like everything is because I am removing the channels. So In Nuke, there is a remove node, remove channel, and it lets you keep or remove certain channels. Now, there's a really cool tool that I found on Nukepedia called K-Remove by Nicholas Gautier. And there's the download link right there if you want to download it. And what it lets you do is it lets you basically unlimited remove with some Python, which I thought was pretty cool. So if I took my Octane render here, you can see that it's set to remove, and you see the channel here. It displays all the layers, and as I start to remove the layers, they actually get removed from the list itself. So you can see ID 01, 02, and I'm just sort of deleting more, and you can just click the plus and you can add as many of these as you want and kind of have fun with it. So I thought it was a really cool tool, and it does also gives you a nice description of what was removed on the node itself. So I thought it was a kind of a nice visual and very, very easy to use. So yeah, go download that tool if you think it is worth using. So you can kind of see what I've done here is basically to isolate the material AOVs. I removed RGBA, I removed the light groups, I removed the IDs, and I removed all the utilities. So then all I'm left with are the material AOV layers. I have also broken out all of the material AOV passes now into their own shuffle nodes, which I've turned the postage stamp on of the shuffles just to get a little visual representation from far away. And I've put a text node under all of them. So if we see here, it says shadows, for example, or specular lighting. And I'm using this ContactSheetAuto node. The ContactSheetAuto came from a tutorial from Ben McEwen. It's a really cool node. Basically, you plug a bunch of stuff in and it kind of auto orders it around. So it makes a nice contact sheet the more stuff you plug into it. So I did set it up so that you can see everything, and you would be able to render this one versus the layer contact sheet node, which, as we discussed, is just a UI thing. So I just set it up here just for you guys to take a look at. Then moving on, of course, we have the light groups. So these are all the light groups as we saw in the slides. And same thing, just a contact sheet version of that you can render out or view. Then we have the utilities. So these are all the utilities for the Redshift render. And finally, we have the ID passes. In the beauty rebuild passes section, underneath the material AOVs and the light groups categories, I posted their rebuilds. So you can see that indeed the passes that are from the material AOVs, for example, they're all separate here and they get added up. So all plus together and they rebuild the beauty render. So if I 1 the viewer on the beauty and 2 on the result, they are exactly the same or nearly identical. And I did the same for the light groups. And so here you see all of the individual lights for the scene here, like so. And if you just add all these up, so we'll go one by one. So you can see the lights are slowly starting to add up to create the beauty render. And the final one is the emission. And if I A/B the beauty with this result, I am also, there's little tiny difference, but it is pretty much identical to the beauty. So that's what these sections are. This is why it's the beauty rebuild passes, because both of these sections should add up to equal the beauty render. So next we're going to look at the Arnold render passes to kind of familiarize ourselves with the differences. And here we're just going to take a look at the material AOVs, and they are slightly different from the Redshift. So if I were to compare the Arnold AOVs with the Redshift AOVs, you can see there are some more passes, like we're missing a shadow pass, for example. But there are a lot of also similar passes. So you can kind of see how they're named and compare the two. I think the Redshift had some subsurface scatter, which is SSS here, but I think the Arnold and the Octane renders did not have that for whatever reason. And for the most part, because the scenes were using the same lights, all of the different lights between the renders are going to be like the same name and the same corresponding light. But even the lighting, you can see slightly changes. So some of the angles are different, and some of the intensities of the lights are different as well. These are things that we could balance out and fix, which we'll probably do a little bit later as like an experiment. But yeah, so all of the lights are corresponding to the same ones in the renders, but you'll see subtle differences between the way that the renders rendered them or the way that the scene was set up between the renderers. And in the Arnold render, we actually have less utility passes than we did in the Redshift passes. You can see all of the Redshift passes that we did get out. So the Redshift one did come with more. Again, maybe it was because we forgot to check some boxes, or it's not the default for the render engine or something like that. But when I'm going over the data passes, I'll just use whichever renderer has the thing that I need when I'm talking about it. So don't worry about that too much. And also the ID passes are going to look pretty much identical between the render engines here, because we kind of made them ourselves. Here you have the Arnold rebuild with the material AOVs, and also the Arnold rebuild with the light groups, so they do match as well for you to take a look at. So finally we have the Octane section, and this is the beauty render from Octane. Here is the material AOVs that were coming out of the Octane render engine. If we compare it to the Arnold and the Redshift renderers, so we have Redshift material AOVs here, then we have the Arnold material AOVs, and then we have the Octane material AOVs. So you see some similarities between all three, you see some differences, some different passes like shadow and light direction here coming out of the Octane one, as well as some filters. So yeah, that would be the differences between all of the render engines there, which we will investigate, take a look at later at a later point of time. Here we're taking a look at the light groups from Octane, and it's the same story. All the lights are named the same as the other render engines were. You can see like a drastic difference between the renders. I'm not sure if we like moved some lights or something. We tried to get it as close as we could within reason, but yeah, sometimes something goes wrong. But once again, it might be a fun test to kind of rebalance all these to look the same, because that is something that we could do later. And down here we have material AOV rebuild from Octane, and this is the light group rebuild from Octane as well. So you see a little bit of difference between the specs, but that's totally fine for the lighting rebuild there. Just like the Arnold render, we have just a few utility passes in the data section for Octane. So we have depth, normals, position, and UV. And as expected, the IDs category has the same passes as the other two render engines do. So have a look at this script, go through it. Maybe you'll learn a little bit more about how I was dividing the render passes and what to remove. Just one note here. When I'm removing all this stuff, that was just for the layer contact sheet. It doesn't matter if you leave in all the channels and layers when it comes to the shuffles, because you're only shuffling out what you need. It was just for the visual contact sheet that I was doing it. So it's not a necessary thing for you to do that in your pipeline or anything like this. I just thought it was useful to see what I was removing to end up with the final layers that were in each category. The last thing that I wanted to leave you guys with was sort of tips and tricks for creating like this nice contact sheet here. I had a message in the comments of the last video about how one could render the layer contact sheet node. So how do you render it if the UI doesn't actually render out. So this would be the solution, really. And I wanted to show you how I did this because it seems like a lot of work, but actually wasn't that much work, and you can probably do it quickly. Maybe you can learn how to do it quickly here if I show you exactly what I've done. So let me just copy this tree here, and I'm going to paste it off to the side. And we could use that as a reference. And I'll just paste another one right here. And let's delete these guys right there. So I'm just going to use this dot. So I don't know if you guys remember, but there was that script to shuffle out the split channels. So we could just do that. And this isn't going to be in a nice order like I made it, but that would work if you just needed to do something really, really fast. But let's say that you actually took the time to shuffle all this stuff or to reorganize all of those. So if you hit Alt P, you can bring up the postage stamps so you can clearly see them, and maybe you would go and shuffle these around so they were in some particular order that you wanted them to be. That's kind of up to you. So let's just say you've organized your shuffles so they're in whatever kind of order that you want or grouping that you want. The next step would be to add a text node that's going to display the layer name. And we could go type that out individually, but that would be a poor man's job. So we're going to do it more automated. So we could bring in a text node. And it's actually the same code that I'm using here. And there's a little bit too much code here, but basically it's just this one, this top one, value in. So what we need to do is we need to say, this is a TCL command, right? So this is, you start with brackets and your code goes inside the brackets, and value is going to list a value of one of the knobs. So all of these sliders and all this stuff is a knob. If I just rest my mouse, you'll see the name of the knob. This one's called global underscore font underscore scale. You can see if I go over another one, it's called kerning. Okay, so that's the name that we need to grab. And in this case, I mean, if I just hover over it, so I'm just going to hover over this diffuse filter, you can see the name is literally just in, right? So that's how I know what I need. So it's going to be give me the value of in, and that's going to give you that value. So if you go to the text, here we go. So let me just make some bigger font here. And we like Arial black, so let's make Arial. Cool. Let's make the font a little pretty too. We can add a shadow, and if I reduce the distance and add the expand and bring up the opacity, I think it was, yeah. So let's give this a nice thick bezel or whatever there. Yeah, cool. So that's looking pretty good. We can also position it any way that we want. So let's not make it in the very corner, but let's make it like here, and maybe something like 2.5. That's pretty good. Cool. So that's where our text is going to show up. Okay, so back on track. So it didn't work. It didn't work. It would work if you were doing, for example, something on this node, because this TCL expression is looking at the current node. So if I, for example, hover over this, it's called font height. So if I were to type in font underscore height, you'll see the number there. Actually, it was cool. If I left it on font, it actually gives you all the settings for the font. So anyways, that's all well and good, but we need the value from the node above it. And that's pretty easy. You just need to put input. So input being the input of that node. And so if I if I type value space input.in, so what it's saying is give me the value of the input node, and then it would be the knob, and in is the knob name. So the node is input because it's grabbing the node that's plugged in, that the text is plugged into. And then it is displaying the name of the layer because that was the the in knob. So once we get it to work once, so once again, bracket value space input dot in bracket. So that's it. And you can obviously take it from one of these text nodes that's in this script, or I'll write it in the blog post so you can do it. So the next step would be, since we have it working, this is going to just work on all of these now. So if I just start pasting these, you will see it just kind of working on all of them, which is great. Now, we probably don't want to manually paste all over the place because, you know, that's also a poor man's job. So there is this Nukepedia Python script called paste to selected. It's a pretty old one. It's been around for a while. I think most companies have it, and most people are using it anyways. But I mean, basically, you copy one thing, you select a bunch of things, and you paste, and it pastes to all of those nodes. So paste at the bottom of all those nodes there. If you are familiar with W Hotbox by Wouter Gilsink, that is this cool panel that comes up when you hit the tilde key or whatever hotkey that you've assigned it to. And it actually is one of the Python scripts that comes with the default icons, or default buttons rather. So it's paste to selection. It's right there. It's going to be on the bottom section. So what we could do is we could take the text node, we can click copy, and then I'm just going to select all of these shuffles, and I'm going to paste to selection. Now, if you had it up here in one of these scripts in somewhere, then you could do that as well. So now we have all of our text nodes that are properly displaying the layer names. So pretty easy. The next step would be to grab one of these ContactSheetAuto nodes, and this does come in the Nuke survival toolkit that I've put together, and it is under merge. So here it is, ContactSheetAuto TL. So there you go. So it's going to come in there. So let's say that we have one of these. So if you start connecting these inputs to the text nodes one by one, you'll see that it's going to fill out this grid and kind of adjust the size and the layout accordingly to how many are plugged in, which is cool. But once again, that's a poor man's task to do that individually. Nuke already comes with a really nice feature, and it's basically a input connector, I suppose. So what you need to do is you need to first select the node that you want to have its inputs connected to. So we're going to select the ContactSheetAuto node, and then this is really important because the order of the selection is going to be the order of the numbers of the inputs. So if you selected it from right to left, then it would go from the text this node emission over here and all the way to the left. But we don't want to do that, so we're going to start over, select the ContactSheetAuto, and then we're going to select, and I'm just going to make a little box selection here, and I'm just going to select all of these texts. So they're going in order of selection from left to right. Then you're just going to click the Y key, Y, and that's just going to connect everything. This also works, for example, on a merge node. So if I did the same thing, if I just select all these, boom, you click Y. It's a nice way to merge a bunch of stuff together. So you have now a contact sheet, and what did I do? I think finally I put a reformat. So because it was very, very big, and so maybe you reformat it down to a reasonable size like HD or something for you to render out for your lighting supervisor or for your VFX supervisor or something to review. So that was kind of a lot to take in. So we could just do it all from the top. So first, I'm going to split my channels. Then I'm going to make one text node. Then we're going to do value input.in. Right? So I have one. Maybe I'll make that Arial. Maybe I'll make that, I think it was 2.5. Give that a little bit of space there. We'll leave out the background drop shadow or whatever. So then I'm going to copy, select all of these, paste to selection. I'm going to grab auto contact sheet node. Boom. So I'm going to select this, and then I'm going to select all the way down and click Y, and boom, you have a contact sheet. There you go. So probably going to need a little bit of time, to get quick on the draw on that one, but it is possible to do it really fast if you have the right Python scripts and tools available. So I hope that was helpful to maybe any lighting artists or anything that often need to present their contact sheets and wanted to do it in a quick and easy way, I suppose. And that is where I'm going to end this video. It was mostly just about the categories and separations of the render passes. And in the next section, we're going to do a deep dive on the material AOVs. And we're going to look at all of them and seeing how we can use them, how they operate, and how we can manipulate them. So I'll see you in the next video.